I'm Kian, and today I want to show you how to find if a series converges or diverges by the ratio test. So we have this series from 1 to infinity of 2n factorial over n to the power of n. So I'm using the ratio test. So the first thing is that we should use this formula that we should evaluate the absolute value of this whole thing is a sub n. So we should evaluate the absolute value of a sub n plus 1 multiplied by 1 over a sub n, the reciprocal of a sub n. So if I do that, so what I get, in the numerator I get 2 times n plus 1, the whole thing times the whole thing factorial, and then over, this is n plus 1 to the power of n plus 1. And the next step is to multiply by the reciprocal, which is n to the power of n over 2n factorial. Now, I can write 2 times n plus 1 factorial as 2n plus 2, so I can write this as 2n plus 2 multiplied by 2n plus 1 times n times 2n factorial times n factorial times 2n factorial. And now you can see that 2n factorial and 2n factorial cancel out, and what we're left of is 2n plus 2 multiplied by 2n plus 1 over n plus 1 to the power of n plus 1 multiplied by n to the power of n. Now, the next step we should do is that we can factor this out, and if we factor this out, we get, I write it here, we get 2 times n plus 1, and also we can simplify this n plus 1 to the power of n plus 1. We can write it as n plus 1 to the power of n multiplied by n plus 1 to the power of 1. So now you can see that this n plus 1 and n plus 1 cancels, and the final result is 2 times 2n plus 1. So we get 2 times 2n plus 1. And then multiply that, because we have these two terms that both have to the nth power, we can write this as multiplied by n over n plus 1 all to the nth power. Now, I'm going to use a special limit because we should take the limit to see if it converges or diverges. I want to show a special limit that I showed in my previous video, and the limit is that the limit as n approaches infinity of 1 plus a over n to the power of b times n is equal to e to the power of ab. So now we see that this is kind of similar, but what can I do to this expression is that I can take the reciprocal of this expression. So I'm not gonna work with this expression, but with this expression. So if I do that, I get n plus 1 over n, and then to the power of negative n. And now I'm in this form, and I can simplify this. I can write it as 1 plus 1 over n, all to the power of negative n, and I'm clearly in this form. So if I take the limit of this, a is 1 and b is negative 1, so I get e to the power of negative 1, which is equal to 1 over e. But we should still take the limit of 2 times 2n plus 1. We're not done. So if I do that, I should take the limit as n approaches infinity of 2 over e, 2 times 1 over e, multiplied by 2n plus 1. And if I clearly put n, I get infinity, and infinity times anything is just infinity. And now in ratio test, we're not done if we found the limit is infinity. We should state that infinity is bigger than, it's way bigger than 1, so our conclusion, I read it here, is that the sum from n equals 1 to infinity of 2n factorial over n to the power of n diverges, because in ratio test, as I explained before, when the limit of the product of the absolute value of the product of a sub n plus 1 and the reciprocal of a sub n is greater than 1, it diverges. If it's less than 1, it converges, and if it's equal to 1, it is not is undefined or inconclusive. Diverges by ratio test. Thanks for watching. Please subscribe and let me know what you do next in the comments.